All right, everybody. So today we're going to look at how binary numbers work. So if you remember what we looked at yesterday, we looked at how bits, which is an individual 0 or 1, can be combined into bytes, which have 8 of them. And how we can use that to translate information and send it to each other. Now, what we're going to look at today is how this information actually has meaning. So we can take a lot of things and break it down into numbers. We can break down text into numbers by giving each number or letter a value. We can do the same thing with music by recording the sound waves themselves and lots of things like that. But all of this relies on us being able to translate actual number values into binary. So we're going to look at that today. So the first thing we're going to do is kind of compare binary to a numbering system that we're used to. So the numbering system we normally use is called decimal. And we're going to compare that to binary. All right, so the first thing to look at is the words themselves. So when we look at decimal, we look at this des or deci prefix, which means 10. For example, a decathlon has 10 events, a decade has 10 years, and you see a lot of words that start with that DEC that mean that they have 10 of something. Binary starts with the prefix bi, which means 2, like a bicycle has 2 wheels, or a biathlon has 2 events. Fun trivia, the 2 events that it has is target shooting and cross-country skiing. And those are the basis of our root words here. Now, why do they have those particular numbers, why 10 and 2? And it's because decimal numbers are what are called base 10 numbers, and binary is what's called base 2 numbers. All right, what does that actually mean? Well, let's look at a regular decimal number. Let's say you have $73 in your bank account. That's kind of pathetic. Let's add a little bit more. Let's say it's $4,073. Okay? Now, if we're going to break this number down, think about the way you did it in like 3rd grade. This is the ones digit. This is the tens digit. This is the hundreds digit. And those are the thousands digit. And notice every time we go up a digit, we're multiplying by 10. And that's what base 10 means, is that each number is based on multiples of 10. So the ones, tens, hundreds, thousands. If we have a base 2 number, a binary number, what it looks like is this. And in this case, we still start with the ones, but the next digit, remember, since this is base 2, instead of multiplying by 10 when we go up, we're going to multiply by 2 when we go up. So this digit is actually the 2's. That 0 there is the 4's, 8's, 16's, 32's, and 64's digit. So that's what binary means. Now we can actually use this knowledge to help us convert a binary number into a decimal number. So for example, let's say we had a binary number. All right. Again, we know our digits here. That's ones, twos, 4's, 8's, 16's, 32's, and 64's. So what we can do is we say, how many ones do we have? Now think about how we would do this, again, if we were doing a decimal number. we'd say, oh, if I had that $4,073, this is my ones, tens, hundreds, and thousands. So what this actually means is that when I say how many ones do I have 3 of them. How many tens do I have? I have 7 of them. How many hundreds do I have? Well, we have 0 of them. And how many thousands do I have? I have 4 of them. And we add that up, we get 4073. All right, we're going to do the exact same thing to convert a binary number into decimal. So I'm going to say, how many ones do I have? I have 0 of them, for a total of 0. How many twos do I have? I have 0 of those also, for a total of 0. How many fours do I have? I have 1, for a total of 4. I also have 1 8, for a total of 8. 1 16. No 32s. And I have 164. All right. Now, just like down here, I took all these and added them together. I'm going to come up here. I'm going to add those together. So 64 plus 16 is 80. That's 88. That's 92. So this equals 92. What this means is if I have a binary number, 1 0 1 1 1 0 0, in binary, and the way we designate this as binary or base 2 is a little parenthesis with a 2 next to it, is equal to 92 as the decimal number, so 92 base 10. All right, let's do one more example here. Sorry, erasing takes a minute. All right, and I'm going to show you a little bit faster way to do it this time. So let's say I've got 1 1 0 0 1 0 1 0. All right, I can multiply by 2 in my head, so I'm just going to start. And the easy way to say this is, do I have any ones? No. Do I have twos? Yep. And I can only have one of them, so it keeps it a little bit simpler. Do I have fours? No. Do I have eights? Yes. Do I have 16s? No. 32s? No. 64s? Yes. And the next number up, notice I'm just multiplying by 2, 128. And what I'll do is I'll just add those together. So 2 plus 8 is 10, plus 64 is 74. 74 plus 128. So our binary number, 11001010, notice base 2, is equal to 202 base 10 when we make it into a decimal number. So that's how we can convert from a binary number into a decimal number. Now we want to be able to go both ways. It's also valuable to us to be able to convert from a decimal number into a binary number. And the trick to this is to remember the place values of things. So let's just pick a random decimal number. We'll say 145. And this is a base 10, it's a decimal number. Now we want to convert that to some number in base 2. And the easiest way to do this is to basically create a system of place values. All right, so all of these are blank numbers. We know the ones goes here, twos, fours, eights, 16s, 32, 64. That's probably not big enough to get all of our values here. 128, and I'm going to keep going until the next number, which would be 256, would be bigger than my initial value. And I know I don't need this, so I can erase it. All right, so what I'm going to do is I'm going to start on this end over here, on the bigger value, and I'm going to say, can 128 go into 145? And it can go in once. Now, if you ever find that something can go in more than one time, you're doing it wrong. You probably need to add more place values out here. But 128 can go into 145 once. And how much do I have left? So I have 145 minus 128. And I'll have 17 left. Now, this one right here accounted for 128 of the 145. I still have 17 left to account for. So can 64 go into 17? No, it's too big. 32 can't either. Can 16 go into 17? It can go in one time. And I have 1 left. Can 8 go into 1? No. Can 4 go into 1? No. Can 2 go into 1? No. And can 1 go into 1? Yes. And I'm left with nothing at the end. And that's as it should be. If you get done and you have things left, you've also done things wrong. So those are kind of your signs that something has gone awry. Let's go ahead and do another example here. So let's say 295 in base 10, and we're going to convert that to some number in base 2. So I'm going to do the same system. There's my 1s, 2s, 4s, 8s, 16s, 32s, 64s, and this is still significantly bigger, so I'm going to keep going. 128s, 256s, and if I add another one, it'd be 512, and this is definitely bigger than my 295, so I know I don't need the 2 or the 512s. So, how many times can 256 go into 295? It can go in one time. And I'm left with 39. Now, if you want to be real clever about it, you can just say to yourself, how can I create 39 from the values here? So I know that I could use a 32, and then I'll have 7 left, and I can make a 7 with a 4 and a 2 and a 1, and all these other values would be 0. So when I go to convert this into my base 2, I'll have 1, 0, 0, 1, 0, 0, 1, 1. And these two numbers, 295 in base 10 and 1, 0, 0, 1, 0, 0, 1, 1 in binary or base 2 are going to be the same value. And that's how I can convert from one to the other. Now, if you're not comfortable just picking which values you need and filling the other ones in 0, you can always just do it the slightly longer way and say, does 256 go in? Yes, it goes in once. And then I have 39 left, and you can say, does 128 go into 39? No. Does 64? No. Does 32? Yes. And I have 7 left. Does 16 go into 7? No. Does 8 go into 7? No. Does 4 go into 7? It goes in once. Start over here. Does 2 go into 3? It goes in once. And does 1 go into 1? It goes in once. And you'll see we'll get the same value here when we're all said and done. All right, so that's how we convert from binary to decimal and from decimal to binary.